Good morning everyone. Today we are going to discuss one numerical of the subject electromagnetic field theory, and the topic is divergence theorem. So we will take this numerical. The numerical is here. This is the numerical. If gr is equal to 10 e raised to power minus 2z in the bracket rho a rho plus az, what we have to find? We have to determine the flux of G out of the entire surface of the cylinder, and the radius of the cylinder, that is rho, is equal to 1, and the height of the cylinder varies from 0 to 1. And there is one more part in this numerical, that is confirm the result by using a divergence theorem. So first we have to find out in which coordinate the question is talking about. Here you can see rho a rho, the unit vector is a rho and a z. That means it is clear that we are talking about the cylindrical coordinate. And here it is also given determine the flux of G of the entire surface of the cylinder. That means we are talking about the cylindrical coordinate. If you draw the figure, then the figure will be drawn like this one. This one. You can see in the figure the flux is coming out from the top of the cylinder. Cylinder is placed in the x, y, z axis, and the radius of the cylinder is rho, height is z, and the flux is coming out of the cylinder from the top, bottom, and from the side of the cylinder. So if you consider the flux coming out, if you consider flux as a psi, and the flux coming out of the cylinder is psi 1 or psi top, and the flux from the bottom is denoted as psi b, and flux from the side is denoted as psi s. So the total flux which is coming out of the cylinder is psi is equal to closed surface integral of G. That means G dot ds, which will be equal to the flux of the top, flux of the bottom, and flux from the side. So we represent it as psi is equal to surface integral G dot ds is equal to psi top plus psi bottom plus psi side. So we have to find it out separately. First we will look at the psi top. We have to calculate the flux coming from the top of the cylinder. That means for top of the cylinder, if you look at the figure, this top of the cylinder, and the height of the cylinder varies from 0 to 1, which is given in the numerical. So the z is equal to 1 and ds. How we will find out this ds? So if you look at the top, for the top, the ds will be rho d rho d phi into az. We have to put all this value in G dot ds. So the side top is equal to G dot ds, which will be equal to integral G. Value of G will be given in the numerical, that is 10 e raised to power minus 2z, and for z we will put value z is equal to 1. So it will become 10 e raised to power minus 2 because z is equal to 1, and the value of ds is rho d phi az. Okay, value of ds is rho d phi d rho into az. If we multiply this with gr, then the unit vector az is multiplied by az, and unit vector az is multiplied by A rho. So what we will get, Az into Az is 1 and Az into A rho is 0. That means the final answer which we will get is 10 e raised to power minus 2 rho d rho d phi. If we solve this integral, and because we are talking about the top of the cylinder which is a circle, so for phi we have to integrate it from 0 to 2 pi, and radius which is given in 1, that is rho is equal to 1. That means we have to integrate it over 0 to 1. So final answer which we will get is 10 pi e raised to power minus 2. So this is the flux 10 pi e raised to power minus 2, which is for the top. Now similarly we will calculate for the bottom. For the bottom, the value of z will be 0 and ds is same as top, but with the difference that the unit vector which is the plus az, now here it is a minus az because flux is going downward. Hence psi bottom which will be equal to g dot ds, we have to find out, we have to put the value of g from the numerical, and ds which we have from, and ds which is equal to rho d phi into unit vector. If you multiply this unit vector to the g, so az multiplied by az will be equal to 1 and az multiplied by a rho is 0, the simple dot product rule. So what we will get, 10 e raised to power 0, because in numerical it is given e raised to power minus 2z, and z we have to put z is equal to 0. That means 10 e raised to power 0, and the value of ds is rho d phi. If we calculate this integral, then what we will get, we will get the psi bottom is equal to 10 pi. So for the bottom we will get a 10 pi, for the top which we have calculated 10 pi e raised to power minus 2. Now we will calculate for the side, flux coming from the side of the cylinder. So for the side of the cylinder we will consider, because it is the outer portion of the cylinder, that means the rho, that means the radius of the cylinder is 1, and the ds is equal to rho dz d phi a rho. This is the value of ds. So for the side is equal to integral g dot ds, which will be equal to integral 10 e raised to power minus 2z into rho square dz d phi. If we calculate this integral for 0 to 1, for z is equal to 0 to 1 and phi is equal to 0 to 2 pi, the result will be 10 pi multiplied by 1 minus e raised to power minus 2. Okay, so the total flux which is coming out of the surface of the cylinder, that is psi, is equal to the flux from the top, flux from the bottom, and flux from the side. And flux from the top which we have calculated is 10 pi e raised to power minus 2 minus, for bottom 10 pi, and for the side 10 pi into 1 minus e raised to power minus 2. If we calculate all these, the final result will be 0. That means the total flux which is coming out from the closed surface is 0. Okay, now we can move on to the second part of the question. Second part, confirm the result by using a divergence theorem. So first we have to understand the divergence theorem. What is the divergence theorem? Divergence theorem states that the total flux, or you can say the total outward flux of a vector field A through a closed surface S is same as the volume integral of the divergence of A. That means surface integral of the vector A dot, so vector A is equal to the volume integral of divergence of A. That is, surface integral A dot ds is equal to divergence of A dv. This is a divergence theorem, and we have to use this divergence theorem to confirm the result. So the total flux will be integral. Now come to the numerical. The total flux will be psi is equal to integral g dot ds, which will be equal to, if you apply divergence theorem over this part, that means g dot ds if you apply divergence theorem on this g dot ds, then what will be the result? The result will be integral del dot g dv. That means divergence of g dv. Now we have to find out divergence of g. So divergence g for the cylindrical coordinate is given as 1 by rho del over del rho into rho 0 plus 1 by rho del by del rho del by del phi into g phi plus del by del z into gz. If you put all this value in this equation, what we will get? We will get 1 by rho into del upon del rho multiplied by rho square 10 e raised to power minus 2z, which is given in the numerical, minus 20 e raised to power minus 2z. If we differentiate it and solve, we will get the answer. We will get the 1 by rho into 2 rho e raised to power minus 2z minus 20 e raised to power minus 2z, which will be equal to 0. That means the total flux coming out of the cylindrical surface is 0. We have solved it by using a conventional method, that means integration of the top, bottom and side, and also we verified this by using a divergence theorem. That means the total flux is equal to divergence of G over a closed volume will be equal to 0. Thank you. In the next lecture we will discuss some more about electromagnetic field theory. Thank you.